Let's first understand what are solids, liquids, and gases. The particles in solids are tightly packed and the forces of attraction among them are maximum, which make them rigid and incompressible. And that's why they have a definite volume and definite shape. And one of the example is ice. The particles in liquids are not as tightly packed as in solids, and so the forces of attraction are also less than them. So this makes them fluid and compressible. And so one of the example is water. The particles in gas are able to move freely, and the forces of attraction among them is also least, which make them completely fluid and highly incompressible. And one of the example is water vapor. So now let's understand the phase change graph. So let's first plot the x and y axis. The x-axis is the heat supplied and the y-axis is the increase in temperature. So we have taken the ice in the beaker, and when we start heating at low flame, the temperature starts increasing, and the ice is a solid form, so we have a graph in which the temperature is increasing, and this represents the solid part. So when we heat further, the ice starts melting, and this part gets constant as the temperature here is 0 degrees Celsius throughout. The ice melts from solid to liquid, and then it's then 0 degrees Celsius. It changes into water. The ice melts into water, and it is represented by this part of the graph. Now when we move further, the temperature increases, and it's again constant because the liquid is now evaporating into the gaseous form at 100 degrees Celsius. The liquid is now boiling, and thus it is converting into the gaseous form, and as you can see, this is constant. And then you can see the vapors are coming out. That means it is now gas or water vapor. So one question arises in the mind when we see this graph: where does the heat go? Here we see 0 degrees Celsius. So where does the heat go? Why it is constant? So the answer to this question is that this heat energy is actually used up in overcoming the forces of attraction between the particles of solid during the change of state from solid to liquid without increasing their kinetic energy. Since the kinetic energy of the particle does not increase, therefore the temperature of the substance does not rise during the change of state. Okay, so this happens in solid to liquid and liquid to gas when there is a phase change. So let's move further. We have some questions related to this graph. What is the physical state of substance at A? It is solid. B, the phase change part, solid and liquid. C, liquid. D is the liquid and gas. It is the phase change part. And E is gas. Let's move further. What is the melting and boiling point of the substance in the graph? Melting is 0 degrees Celsius. Boiling is 100 degrees Celsius. Or we can say melting is 273 Kelvin or 373 Kelvin. So let's see. The boiling point of the substance is 373 Kelvin and the melting point is 273. Therefore, the substance is water. What happens to the temperature when the substance is changing its state? When the substance is changing its state, B and D, we can see these are constant. Therefore, we can say the temperature is constant. Let's see. When the substance is changing its state, its temperature is constant.